everyone. My name is G. Shankar Varma, Assistant Professor of EC Department, Marri Laxman Reddy Institute of Technology and Management. So I am going to teach a subject called Electronic Circuits, and it is for second year, second sem EC students. And the prerequisite of this subject is Electronic Devices and Circuits. And now this is my second online session of this subject, Electronic Circuits. So in today's session, we are going to discuss about approximate analysis of Bjt as well as cascade amplifiers. So to understand the cascade amplifiers, we have to know about the approximate analysis of Bjt. So coming to the syllabus, in the previous class, I have covered classification of amplifiers from unit 1, classification of amplifiers, distortion amplifiers, different coupling schemes used in amplifiers, frequency response, and analysis of multi-stage amplifiers. Now we are going to study about this cascading amplifiers. As I told earlier, to study about the cascading amplifiers, thoroughly we have to know about the approximate analysis of Bjt. So coming to the approximate analysis of Bjt, so as I told earlier, in the prerequisite subject called Electronic Devices and Circuits, in the first year, students have already studied about these concepts called exact hybrid model or exact hybrid analysis, and second one approximate hybrid model or approximate analysis. Hybrid model or analysis, both are same. So this exact hybrid model completely deals with the single stage amplifiers, and the approximate hybrid model completely deals with the multi-stage amplifiers. So our unit name is multi-stage amplifiers. So here we are going to study a topic called cascade amplifier. For that we need to know about approximate hybrid model. So approximate hybrid model completely covers multi-stage amplifiers, and exact hybrid model which covers single stage amplifiers. That means single stage amplifier means we are going to study about either CB amplifier, CE amplifier or CC amplifier alone. We are not going to connect any another circuit to it. Multi-stage amplifier means more than one is said to be multi generally. That means here we will study about two-stage amplifiers. That means we will connect different combinations or same circuits. Like CE, CC we may consider connect, or CEC we may connect, or CC, CC we may connect. CE means common emitter, CB means common base, CC means common collector configurations of bipolar junction transistor. So these are the different books that we need to refer for this subject, electronic circuits. So coming to the approximate analysis of Bjt, in the coming slides, I have drawn the approximate analysis for common base, common emitter as well as common collector. Why do we need these circuits? Why? Because to perform the analysis of a two-stage amplifier, I mean for multi-stage amplifier, like cascading techniques, there we will do the analysis part with the help of approximate model only. We will analyze the circuit and we will find different important characteristics like current gain, voltage gain, input resistance and output resistance of the multi-stage amplifier. So coming to the approximate analysis, so this is the approximate analysis of CE amplifier. So here if you observe, actually we have drawn this from exact model only by considering few parameters. So here at the input side we are having input resistance, output side output resistance. This is also output resistance, R0 dash we will consider across the output voltage V0. So this is about the approximate analysis of CE amplifier. And now this figure, second figure, represents the approximate analysis of CC amplifier, as well as this figure represents the approximate analysis of CB amplifier. So this approximate analysis of CE amplifier, CC amplifier, CB amplifier, where do we use? Means we will use for the analysis part of two-stage RC couple amplifiers. So this is the table of formulas which represent important characteristics of CE, CC and CB configurations. So this first column represents AI, RI, AV, R0 formulas of CE amplifier. and this second column represents AI, RI, AV, R0 formulas of common collector configuration, and the last column represents common base configuration, different important characteristics. Here AI means current gain, RI means input resistance, AV means voltage gain, R0 means output resistance. So these are the very important formulas. In cascading, we are going to explain 3 steps total will be there. In step 1, we will going to draw individual approximate analysis. In the step 2, we are going to combine those 2-stage approximate analysis. In the third stage, we are going to do this analysis part. There we need these formulas, AI, RI, AV, R0, right? So we'll see one by one. So coming to the topic, cascade amplifiers, that is the introduction for approximate analysis. Now we will move on to the cascading amplifiers. So before going to read about the cascading amplifiers, why do we have to connect these amplifiers? Cascading is nothing but a series combination or series connection of 2 different amplifiers. Why we are going to connect 2 different amplifiers? Let us assume a scenario where we are addressing around 50 people, right? There we do not require any mic and all, right? Loudspeaker mic, there we did not require those things. But wherever, let us assume we are going to address some 100 people or 500 people, there we need these connections, loudspeaker, mic and all, everything, right? So in that case, what will happen? Let us assume we are talking, our speech signal will be like this, okay? Let us assume it is a low signal. And after applying to the amplifier, it will be amplified like this, okay? And let us assume it is not sufficient. Our speech signal is amplified a little bit, but it is not sufficient to cover some hundreds of people. There we have to connect another amplifier also. So after this, it will be amplified like this. So these 2-stage amplifiers will present in the loudspeakers. So most likely in the public addressing systems, we will use this multi-stage amplifiers concept. Public addressing system means if we go to a bus station or railway station, announcement will be there in which platform, which train is coming, and how much time it will present in that platform, and all those details will be covered using this public addressing system, right? So in those public addressing systems, there we will use this multi-stage amplifiers. So based on our requirement, we are going to connect different amplifiers like CE, or CECC, CCCC, like that. So as an example, in this section, I am going to discuss about, first we will see CECC amplifier. That means 2 different amplifiers. If we connect, what will happen, we will see. After that, as a second example, we will see same amplifiers we are connecting as 2-stage, like CECE amplifier, right? So coming to the cascade amplifiers again, why do we use cascade amplifiers? When the amplification of single stage is not sufficient, we go for generally multi-stage amplifier cascading. So why we are going to connect it, and what are the benefits we will get? By connecting in multi-stage amplifiers, the gain, like voltage gain or current gain, will be improved. That's why we refer cascading. So as I told earlier, in this section, we are going to discuss about CECC amplifier as well as CEC amplifier. First, we will see CECC amplifier. So this is the general circuit diagram of CECC amplifier. Here, Q1, Q2 is there. Q1 represents first stage and Q2 represents second stage. In the first stage, we will connect CE amplifier, right? This is first stage. In the second stage, we will connect CC amplifier. So this part, Q2 part is CC amplifier. That Q1 transistor part, that is first stage CE amplifier. In a CE amplifier, as we all know, the input is base terminal, and we will collect the output across collector terminal. For common collector configuration, here input is base terminal and output we have to connect across emitter terminal. Okay, right. That is just a circuit diagram of it. So as we have seen earlier, cascading will be done with the help of 3 steps. In the step 1, what we have to do is we have to draw the approximate analysis of first stage as well as second stage. In the step 2, we are going to combine the approximate models of those two stages. In the third step, we are going to derive the important formulas or important characteristics related to those two stages. Okay, we'll see one by one. So here we'll start the step 1 of CECC amplifier. The step 1, what we are going to do now, we have drawn approximate model of CE. In this slide, we have drawn approximate model of CC. This is about step 1, just drawing the approximate models of first stage as well as second stage. In the next step, what we are going to do now, we are going to combine these two. In the first stage, this circuit will present approximate model of CE. Just we have to detach this RL part. That means we have to remove the RL part, and we have to remove the input stage VSRS from the second stage, and we will combine these two. Just we will detach RL from first stage, and we will detach VSRS, and we will combine. So it will be like this. See, if you observe this circuit cascading of CE and CC, up to here, this dotted line, this entire circuitry represents approximate model of CE. After these dotted lines, the entire circuitry represents CC, approximate analysis. So now what we have did, cascading means simply we are going to connect the approximate model of first stage as well as second stage. In the last step, what we are going to do, our aim is to find out voltage gain, current gain, input impedance, output impedance, etc. Those we will find, and we'll see how we are going to write it. So in this third step, if we observe analysis of second stage, that means CC amplifier, formulas I have written. Analysis of first stage, C amplifiers, formulas I have written. From where we got these formulas, if you remember, this table, characteristics of approximate models, we have earlier tabulated these values, right? From here I have written here. So this is about CECC amplifier cascading connection. Now we will see the second example as same type. We are going to connect two stages, that is CE amplifier. That means in first stage CE present, second stage also CE will present. Same type we are going to see. So here, as we discussed earlier, this Q1 represents first stage, that is CE, and this Q2 represents second stage. Here also we have connected CE. So as we discussed earlier, now we will see same type of amplifiers connected in two stages. So step 1, as usual, we will consider the approximate models. So here first stage, second stage, we are considering same type only, common emitter. So that's why I have drawn only one approximate model, which will usually present for first stage as well as second stage, that is CE approximate analysis. So coming to the step 2, we are going to combine approximate model of CE as well as approximate model of CE. If you observe carefully, same here, we have to, from the first stage, we have to detach RL. From the second stage, what we will do? We will detach VS and RS. Simply connect it. That's all. In step 3, as we all know that, we have to write the important characteristics, right? Important characteristics like current gain, input impedance, voltage gain, output resistance, etc. So that's all about cascading of amplifiers. So before going to study about the cascading of amplifiers, we have to study these approximate model. We have to study this approximate analysis of BJT. Right? Try to remember the approximate analysis diagrams, how we have to draw, everything we need to practice. Okay. So in the next session, we will see Darlington pair as well as transistor at high frequency, that is hybrid pi model. So we will meet in the next session. Thank you.